fall into the old examiner trap. Listen to the roots and put it on the map. When they ask you what makes a center chiral, give them the truth that's bound to go viral. It is a single carbon atom attached to 4 different groups around you. No, don't say elements, elements. Don't say molecules, molecules. Say 4 different groups to pass the exam pool. Feel the chiral vibration, stereoisomerism in the soul. Optical isomers make the memory whole. They rotate the plane, plane polarized light. In opposite directions we get it right. Rotate the plane polarized light in opposite directions tonight. Now pull up the rhythm, take a look at the twins and antiomers form where the mirror begins. Non-superimposable structures we see like a left and a right hand in chemistry. But if you mix them equal 50-50 display. A race mixture is coming your way. Equimolar proportions of both enantiomers inside, with 0 optical activity, nowhere to hide. The rotations cancel out. That is the shout, leaving no net rotation without a single doubt. Feel the chiral vibration, stereoisomerism in the soul. Optical isomers make the memory whole. They rotate the plane, plane polarized light. In opposite directions we get it right. Rotate the plane polarized light in opposite directions tonight. Phonetic sound for the structural eyes. C4H6O rising up to the sky. Asymmetric carbon, asymmetric space. Put the little asterisk right in its place. Mark that chiral carbon with a star. Show the WJEC examiners exactly who you are. Organic revision down in the laboratory. Enantiomers balancing the revision story. Rotations cancel out. In the mix, another segment locked by the Alchemix. The Alchemix, listen to roots, reggae and reactivity. Yeah, listen close to the benzene story. Six carbons in a ring, watch the planarity. sp2 hybrid, that's the reality. Sideways overlap, POB2's align. A cloud of electrons shining divine. Not static double bonds, don't be misled. It's a delocalized cloud, keep that in your head. Stability high, energy low. This is the structure that you need to know. Oh, it's the aromaticity. Delocalized soul, that's the chemistry. Electrophilic substitution is the way. Substitution, not addition, saves the day. Don't break the ring, keep the cloud intact. This is the scientific aromatic fact. Now bring in the nitronium, the E+, NO2 2+. Formed from nitric and sulfuric, that's a must. The ring attacks, it's an electrophile. The intermediate horseshoe sitting in style. Positive charge, delocalized around in the proton leaves. The stability is found. Substitution done, the aromatic stable, strong, sealing the fate. Why not addition? Addition would mean breaking the cloud. Energy cost is far too proud. Destruction of the pi system we won't allow. The stable ring persists here and now. Yeah, just substitution. Oh, it's the aromaticity. Delocalized soul, that's the chemistry. Electrophilic substitution is the way. Substitution, not addition, save the day. Don't break the ring, keep the cloud intact. This is the scientific aromatic fact. Delocalized soul, the Alchemix signing out. Keep that ring intact. Students, the Alchemix on the version. Track and unit 4.3. Do not get caught in a trap. Watch the baseline step. Listen close. Let the rhythm tell the difference. Phenol versus alcohol. Let's drop the beat. Look at the structure sitting side by side. Two functional groups where the options divide. Aliphatic chains where the single bonds align. An alkyl group attached, that's an alcohol design. But when the hexagon ring takes the stand, and no H attached directly to the phenol, and that is phenol. Do not call it the same. Examiners watch if you misread the name. Phenol is weak in a baseline state. It will not react with the carbonate. No gas evolve. No gas. Sodium hydroxide, yes it dissolves. Acidic properties cleanly evolve. Across of the hydrogen carbonate test. Phenols, it's quiet while the acids contest. Sodium hydroxide, yes carbonate, no. Yes, now bring the test tubes, clear out the space. Electrophilic substitution in the ring takes place. Bromine water drops down into the solution. A brand new mechanism, that alkene convolution. The ring activates, it's a fast reaction path. 2,4,6 tribromophenols is the aftermath. A white precipitates settles on the floor, while the orange bromine color is no more. Phenol is weak in a baseline state. It will not react with the carbonate. No gas evolve. No gas. Sodium hydroxide, yes it dissolves. Acidic properties cleanly evolve. Across of the hydrogen carbonate test. Phenol sits quiet while the acids contest. Sodium hydroxide, yes carbonate, no. Yes, iron 3 chloride. Drop it in deep. A purple complex makes the variables leap. That's the diagnostic vibe that you need to report. Don't confuse your observations in the crown chord. And if you wanna make an ester on the line, ethanoic acid will not design. You need ethanoyl chloride to make it go through. Stronger acylation is the master clue. Ethanoyl chloride. So check your details, write them down clear. WJEC guidelines. organic revision crew. The Alchemix on the console, checking the carbonyl line. WJEC specification 4.4. Let's go. Look at the structural line. Look at the carbon group. A carbon double bond oxygen. Yeah, that's the functional truth. If it's locked at the end of the chain with a hydrogen friend, that's an aldehyde. An alkanol blend. But if that functional group is strictly sitting inside between two carbon blocks where no anhydrogens hide, that's a ketone. An alkanol name. Smooth lovers rock rhythm playing the carbonyl game. Oh, carbonyl reactivity. Aldehydes and ketones under scrutiny. Oxidize the aldehyde. Tolerance gives a silver mirror shine. Feelings turns red, precipitate every single time. But the ketone sits cool, it won't react at all. Mild oxidizing agents leave it standing tall. Yeah, clear distinctions on the exam paper sheet. Secure those top marks, make the syllabus complete. Now bring in the reducing power, make the alcohol return. Sodium tetrahydrodoberate 3 is the reagent we learn. Sing it out for the engine, NaBH4. It reduces them both, let's settle the score. The aldehyde steps down to a primary out. The ketone forms a secondary, no time for cheap talk. Don't use LiAlH4, that's for the acid domain. Keep it smooth with the lovers rock reggae strain. Let's track the mechanism step by step in the groove. Nucleophilic addition. Watch the electrons move. The carbon is delta plus. Drawing the attack cyanide. INC and minus hits from the back. The pi bond breaks up to the oxygen space. An alkoxide intermediate takes its place. Then protonation follows. A hydrogen ion bound. A hydroxy in a trial molecule is safely found. Oh, carbonyl reactivity. Aldehydes and ketones under scrutiny. Oxidize the aldehyde. Tolerance gives a silver mirror shine. Feelings turns red, precipitate every single time. But the ketone sits cool, it won't react at all. Mild oxidizing agents leave it standing tall. Yeah, clear distinctions on the exam paper sheet. Secure those top marks, make the syllabus complete. Watch out for the diagnostic trap that examiner set. The triadomethane test a high yield mark to get. It hunts for the methyl carbonyl group CH3CO, or the secondary precursor alcohol you must know. Add the alkaline iodine, heat it smooth and light. Listen close to the observation, get your vocabulary right. It is a yellow precipitate, a solid in view, not a yellow solution. The Alchemix keeps it true. 2,4-dinitrophenylhydrazine tests for the whole carbonyl crew. An orange-yellow solid precipitate proves that it's true. Then purified by recrystallization. Check the melting point line. Small range for melting means the job was just fine. Carbonyl unit mastered, exam confidence high. Yellow precipitate, don't say solution. Smooth reggae sign off, Alchemix sailing by.
Rhythm drop for the chemical crew. The Alchemix.
Underline. Checking the unit. 4.5 specification. Spelling out the derivatives. WJEC style. Watch the ladder of acidity. Drop the bass. Step up to the ladder. Look at the relative scale. Carboxylic acids at the top, they never fail. Then comes the phenol sitting in the middle zone. Then water, then alcohol at the bottom of the bone. Why does the acid win the stabilization race? Because the carboxylate and delocalizes its base. The negative charge spreads out across the oxygen space, across the pi system, leaving no localized trace. For the alkoxide ion keeps its charge locked tight on a single oxygen atom, so it loses the fight. Carboxylic acids and derivatives we trace unsolved, rocking the functional space. Oxidize the side chain, watch the methyl group transform. Alkaline KMNO4 makes benzoic acid the norm. Then acidify the mixture to complete the step clean, securing every single mark on the exam screen. Now pull up the selector, look at the reduction line. Students drop marks here almost every single time. If you want to reduce a carboxylic acid right, do not use NaBH4, it hasn't got the might. You need LiALH4 in dry ether to react, to reduce that acid to a primary alcohol fact. Then if you have a neutral group, C and triple bond line, LiALH4 reduces it to an amine. So fine, keep the solvent dry, keep the conditions set clear. No misconceptions inside the atmosphere. Now elevate the derivatives, prepare the acyl line. SOCl2 makes the synthesis aligned. Phenol chloride, ionil chloride. It's the premier choice to make to form the acyl chloride with no purification mistake. Why? Because the co-products are gases in the air. SO2 and HCl bubble out of there, leaving the acyl chloride reactive and pure. An absolute examiner favorite for sure. Carboxylic acids and derivatives we trace unsolved, rocking the functional space. Oxidize the side chain, watch the methyl group transform. Alkaline KMNO4 makes benzoic acid the norm. Then acidify the mixture to complete the step clean, securing every single mark on the exam screen. Let's link up the nitrogen pathways before the rhythm ends. Amides and nitriles are chemical friends. Eat the ammonium salt to drop a water molecule clear, and the primary covalent amide will quickly appear. Dehydrate the amide with P4O10 heat, and the nitrile functional group makes the pathway complete. But if you add aqueous acid or alkali to the mix, hydrolysis brings them back to the acid matrix. Derivative dub, complete digital baseline done. Acidity scale and reagents completely won. Avoid those errors, learn this syllabus track. Unbeaten baseline, keeping chemistry on track. Chemistry students, adjust your dials. Unit 4.5 and 4.6 crossover. Let's talk about nitrogen lone pairs. Drop the baseline, nice and steady. Yeah, rock steady. Hey, look at the Basicity ladder. Look at the rank, we are stepping it out on a rock steady skank. And amine is a base because it acts as a host. It accepts a proton when it's needed the most. But the strength of that base is a variable thing, depending on what is attached to the ring. Aliphatic primary amine is sit high at the top, with an alkyl group giving an electron drop by a positive inductive effect. Don't you see? Increasing the electron density on the NH2 free. Oh, the aliphatic lone pair is ready to fight. It accepts a proton with all of its Listen to me, do not say benzene ring without hyperdegree. The lone pair of electrons on the nitrogen space delocalizes right into the ring's pi system place. The pair is less available, now to accept a proton, and that is just how the aromatic amine loses all of its power. Sitting right at the bottom of the basicity tower. Oh, the aliphatic lone pair is ready to fight. It accepts a proton with all of its might, but when the nitrogen bonds to a benzene ring, the basicity drops. It's a different thing, yeah. The phenylamine lone pair will fade away into the delocalized system to stay. Now how do we synthesize this phenylamine? Reduce nitrobenzene on the laboratory scene. You need tin symbol lesson and concentrated HCl. Refluxing it together makes the synthesis swell, but it forms a phenylammonium salt in the tray. So you add sodium hydroxide to clear it away, to liberate the amine. Get it free, get it right now. Cool down the mixture, keep it tight, keep it white now. Freeze up the reaction, ice water control. Diazotization is the name of the goal. Add phenylamine to cold nitric 3-acid line, made in situ from sodium nitrite and HCl fine. Keep the temperature low, keep it under 10 degrees. 0 to 5 is the ultimate squeeze. If you let it warm up, the examiner notes the benzene-diazonium chloride floats, decompose into phenol and then 2 gas bubbles, bringing your exam mark straight into trouble. Keep it cold, 0 to 5, don't let it bubble. But if it stays cold, let the coupling begin. Add an alkaline solution of phenol right in, or naphthalene 2O for a vibrant display, synthesizing a beautiful bright azodized spray. The N double bond N is the link in the core, acting as the light absorbing chromophore, absorbing the visible wavelength so clean, reflecting the colors on the practical scene. The Alchemix signing off on this rock steady beat. Unit 4.6 is officially complete. Lone pairs, delocalized, synthesis clear. Keep your temperatures down throughout the year. Basicity mastered, indicator set true. Rock steady revision for the chemistry crew. Unbeaten, basicity logic. Pick up your Alchemix. WJEC. Chemistry massive. We're building chains today. Listen. Oh. Amino acid, building blocks, see the central carbon lock. 4 groups attached, yeah, that's the deal. But glycine's a corrode, that's the seal. Alpha amino, that's the name of the game. And the with the ion form, the structure's not the same. At the isoelectric point, see the charge go to 0. Text, cruise, yeah, the biochemical hero. Splitter ion, keep the pH in check. Splitter ion, give the protein respect. From the binary sequence to the 3D fold. Science and the metal stories to be told. Peptide bond, that's the amide link. Condensation reaction, what do you think? Release a water molecule, lose the H2O. Hydrolysis brings it back, watch the structure flow. Primary structure, just a sequence in a line. Secondary structure, H bonds make the alpha helix shine. Beta P the cheats, yeah, they're looking so neat. Hydrogen bonds holding steady, feeling the heat. Tertiary told in the 3D design. Don't just say bonds, draw the line. Disulfide bridges strong as the steel. Ionic interactions, the electrostatic field. Hydrogen bonds and van der Waals forces too. Stabilizing the shape, that's what they do. Splitter ion, keep the pH in check. Splitter ion, give the protein respect. From the primary sequence to the 3D fold. Science in the meta stories to be told. WJEC! The Alchemix! Yeah. Yeah. We taking the path today. Step by step, follow the route. Organic synthesis, no room for doubt. You got a molecule, but you don't know the name. Start with the analysis, that's the starting game. Mass spec tells the mass, the molecular ion peak. IR tells the bonds, that's the info that we seek. NMR shifts, find the types of carbon chains. Check the adjacent carbon, don't be a fool. M+1 rule, M+1 rule. Count the protons next door, stick to the school. We walk the synthetic path, step by step we grow. From the halogenol K, watch the synthesis flow. Oxidize the alcohol to the carboxylic call. Follow the conditions, so you don't stumble or fall. Ooh, the synthetic path, keep it steady now. Keep it steady now. Now you got your product, but is it pure and clean? Wash it, dry it, separate. Keep the glassware mean. Distillation for the liquid by the boiling point. Recrystallize the solid to keep it on the point. Check the melting temperature for the purity test. If it's sharp and it's rangeless, you've done your best. Check your yield state symbols. Check the yields, check the mass. Keep it in the controls. Common error alert. Don't mix up the addition with the condensation. Addition gives you one condensation, kicks out water. That's the true sensation. Watch your units on the moles. Watch your scaling too. The path is clear. Success is waiting there for you. We walk the synthetic path. Step by step we grow. From the halogenol K, watch the synthesis flow. Oxidize the alcohol to the carboxylic call. Follow the conditions, so you don't stumble or fall. The Alchemix, Unit 4 completed. Chemistry.